5 seconds and counting. Dragon spacecraft is on internal power. SpaceX is go for launch. 10, 9, 8, 7, 6, 5, 4, 3, engine ignition. We have liftoff of the SpaceX Falcon 9 launch vehicle carrying the COTS-D crew to rendezvous with the International Space Station.
Approach Max Q. Max Q.
Main engine cutoff confirmed.
Stage separation confirmed.
Second stage ignition confirmed.
Standing by for escape tower jettison.
Escape tower jettison confirmed.
All systems are nominal for Dragon separation.
Dragon separation confirmed.
Ready for approach initiation.
All systems are go for final approach.
Dragon is on final approach.
Confirmed. Docking is complete. Preparing for ingress.
All right. So that's certainly what we hope will come true at some point. You know, as I mentioned, we've really worked hard to make sure that the crew version of Dragon is minimally different from the cargo version. So there's only one major development item which is the launch escape system that is needed for crew carriage. All right. I think that's sort of in a nutshell the situation with SpaceX, and I'm happy to take any questions from people. Yeah, that's a good question. So it's just about recovery of the stages. So in the case of Falcon 1, we do intend to recover the first stage of Falcon 1. And in the, what we've discovered is that the reentry conditions, even for first stage, are really quite difficult. So it really gets battered around pretty hard. It sees loads up to 16 to 18 Gs, and it does see quite a bit of heat as well. So in the upcoming flight of the launching of the Malaysian satellite of Falcon 1, we actually took the parachute recovery system off because we know that we don't have enough thermal protection for the stage to survive. So therefore, there's no point in having the parachute on. And in order for us to put enough thermal protection on, we would potentially affect we would affect the amount of mass margin, and we just don't want to take any unnecessary risks at this stage of the game. Now, for Flight 6, which is the one after this one, we will be putting on the thermal protection and the parachute and everything. So we will make a concerted effort to recover Falcon 1 Flight 6 of the first stage. For Falcon 9, we don't have any real limitations for the first flight on payload margin because it's not carrying a full payload or a real satellite or anything. It's just carrying a dummy payload. So there's plenty of mass margin for thermal protection system. So we are going to try to recover the first flight of Falcon 9. And it's possible that the first flight of Falcon 9 may actually get recovered before the first of Falcon 1. But again, that is sort of very much an optional thing at this point. It's a requirement in the long term, but it's, as far as I'm concerned, but it's optional in the short term. So we don't want to have any development delays or risk any missions due to temperature stage recovery. And we had intended to have the first flight of Falcon 9 attempt to recover both first and second stage, but we sort of gave up on recovering the second stage in the initial flights in order to bring in schedule margin. So, but long term, the intent with both Falcon 9 first and second stage and the fairing is recovery. But this is going to be a tricky thing that takes us years to figure out, and I wouldn't, it could take us, 3-4 years to get it right. And then, of course, once you get the stage back, you've got to say, okay, now what do we need to do to get this thing ready for flight again? And so there's going to be a learning process, even once we start getting them back, which is, okay, we've got to improve the thermal protection here, we've got to strengthen parts there, we've got to do this, that, and the other thing to make it an efficient recovery process. Because it's not enough that you recover it, it's got to be efficiently reusable. So. Right. Well, I wouldn't want to comment on the prospects for another system, but I can say for Falcon 9, you have to say cost per pound to LEO. Well, it depends on what's your altitude and inclination, and is that as part of a spacecraft system. For example, in transferring cargo to the space station, you really need something that's going to go and dock or berth with the space station. And then that spacecraft itself takes up quite a bit of mass. So, for Dragon, for example, it's about a 3 metric ton of payload capability to space station. But if you were to say Falcon 9's capability to nominal LEO, say 250 nautical miles launch due east from the Cape, type of thing, that would be about 21, 22 tons oh, sorry, at 21 to 22,000 pounds, I should say. And you're talking about a approximately $40 million vehicle. You know, so maybe a couple $1,000s a pound type of thing. Yeah, so now that assumes no reusability. Over time, if we're able to make reusability work, then you can, to the degree that you can make reusability work, you can get rid of the capital cost of the vehicle, or reduce the capital cost, and then ultimately you could see a cost per pound to orbit that's measured in maybe a couple $100s, you know, $200-300, something like that. But the only way to get there is with very efficient reusability, and that's a very tough problem, and no one's solved that yet. We're hoping to solve it. We're sort of aspiring to solve it, but we've got a long way to go before we do that. Okay, we do believe we can address the gap, or at least a large part of the gap. Our estimate is somewhere around, call it roughly 2.5 years from when COTS-D is exercised, or some version of COTS-D is exercised. That's the point at which we could be delivering crew as well as cargo to the space station. So, you know, we think we could probably do this certainly in 2012, you know, so we wouldn't necessarily be able to. You'd still need kind of Soyuz activity for 2011, which is already planned, by the way, and probably the wise move would be to have also some Soyuz flights planned for 2012, and I know. NASA Space Operations wants to actually ensure that there is overlap of whatever the, you know, so that there isn't any gap, say, between if we were late or some other system was late. They want to make sure that there's overlap between them. So I think we can address most of the gap from, say, I'd say comfortably from mid-2012 onwards. As far as the stimulus money, I think that's still in flux, so we don't know exactly what will happen with that, and probably the new NASA administrator will have a say in how that money is applied, but we don't currently have high visibility into what will occur with the stimulus funds. There was actually $400 million allocated to exploration in the stimulus, and then 150 for sort of a mixture of commercial crew activity, and then of that 80 was, but I don't know, the deck could get reshuffled with the new NASA administrator and also with the Augustine Commission. How would I describe the differences between, say, the internet, cars, and rockets? Okay. Well, the advantage that the internet has is that you can create a company with relatively small amounts of capital. So you don't necessarily need to come into it with a bunch of capital. When you're dealing with cars and rockets, those are high capital activities. So it's difficult to create a company in those arenas. Comparatively speaking, more difficult than it is in the internet arena. One of the advantages I had was coming into the space arena with capital from sale to internet companies previously. So I think it's probably a good idea to try to acquire some capital by whatever means before entering either the space or cars business, and probably be prepared to lose a large part of it. But I think things will actually turn out okay from a capital return standpoint on both the SpaceX and Tesla. But it's certainly far from a certainty in these endeavors. It's and I think there needs to be some non-economic motivation as well, because I think if you, certainly for me, and I think logically for most people, if you rank ordered the highest return on investment industries to go into, you probably wouldn't have rockets and cars at the top of the list. There are places where you could probably earn a higher return, risk-adjusted return than the car business or the rocket business. But I think they're also, quite interesting and rewarding because I think these are things that really matter to the future. So. Well, SpaceX, we do want to, like I said, improve the cost and reliability of space transport, and we also do want to scale it up. So, we're going to do the Falcon 9 Heavy. We'd like to do vehicles that are even bigger than the Falcon 9 Heavy. But of course, we need to be able to afford that. So we're just sort of going to keep trying to make progress. And, I think there's a good chance that we'll be able to afford to do bigger rockets than even Falcon 9 Heavy. But we need to have an ongoing business and then be able to fund that either through internal R&D dollars or potentially if NASA or the DoD wants to fund a big rocket program, then that would make it a lot easier. Right.
So free solar rockets, solar panel rockets and cars. How would you compare those hardware those kinds of industries for capital?
Well, fortunately, I don't need to spend much time on the solar side of things. It's probably less than 5% of my time on Solar City, and Solar City is actually. Not in the business of producing the panels themselves, but they're kind of like Dell Computer, where they manage the end customer relationship, they do the design of the overall system, they put the pieces together and manage the service and all that. But just like Dell, they don't make the CPU or the hard drive or anything like that. So Solar City is partly a hardware business, but probably more a service business than it is hardware production. And so actually, on a return on capital basis, Solar City will probably be the highest return on capital of all three. But like I said, I think I'm cautiously optimistic about both SpaceX and Tesla on return on capital being not bad. I mean, not the best place that one could have deployed capital, but pretty good in the grand scheme of things. I don't know which one whether between SpaceX and and Tesla, which one will have a better return on capital, but I would say probably comparable, but it's hard to say at this point.
Please don't step down yet. If I could, please, Brett Silcox, come to the foyer, the podium. We'd like to present Elon with the National Space Society's Wernher von Braun Memorial Award. This is the 7th von Braun Award, with the winner decided by a vote of the NSS Awards Committee during odd-numbered years. It's given to recognize, let me get this right, excellence in management of and leadership for a space-related project where the project is significant and successful, and the manager has the loyalty of a strong team that he or she has created. Elon, you and the SpaceX team have certainly accomplished this with the Falcon 1, and you're well on your way to doing the same with Falcon 9 and Dragon. The award consists of a representation of the von Braun ferry rocket design during the 1950s, beside a Saturn V on a base inlaid with black granite. The NSS is proud to present you with the Wernher von Braun Memorial Award. Congratulations. Continue eating if you still have food on your plate. We'll start sessions again at 2 o'clock, as I understand it. So, thank you for coming.